Hi folks, I'm Mr. Shrego, and today we're going to be working on Activity 2, Think Like a Physicist, on page 10 in your packets. If you want to go ahead and flip there, make sure you've got a pen out and something to think about. Let's get started. For me, I'm thinking about number 1 here, right? Think about an object that is moving while changing its velocity. In my case, I'm thinking about my dog. Just now, she was basically sitting still, just trotting around, and ran off to see her friend Charlie. So I'm starting out with a dog running. Right. If I want to describe her motion using words, I might say that my dog, mine's name is Winry, sped up from rest to go see her friend. Now, if we want to think about how we could measure her motion, right, well, I could use a video. From that video, if I'm able to measure the distances used in the video, using a tape measure, I can get distance. I could go back and look at the area she ran in, and I realize I can actually see her do this on my security camera out back. So I've got a video and distance, and you know what all videos have? They also include time. So I've got a couple important variables here. Now, one little thing though I might want you to think about is, when you're sitting at rest, well, if she's just sitting there, we know how fast she's going, right? We happen to know that V1 is 0 meters per second here. We're going to use that in a minute down the road. Now, let's jump on down here. And if we're thinking about this, we need to think about what things can we figure out, what things can we measure in this case. Now, for me, if I'm thinking about one thing that's going to be more challenging to measure directly, it's her acceleration. In order to do that, I would have to strap an accelerometer to the dog and collect data using a phone and some various tools. That's just more than we're able to do right now, especially all of you at home. Now, if we want to think about the 4 equations and what we might be able to do, well, we've got to go and find one of these that doesn't include acceleration, because I don't honestly care about her acceleration right now. I'm curious about how fast she's going to end up going. So if I'm looking over here, well, number 3, it has acceleration in it. I don't really care about her acceleration. I don't really know her acceleration, right? That's something I might want to find out down the road. Right now, I'm more so curious, how fast does my dog actually go when she runs off to see someone? Equation number 4 there, that has acceleration in it. Oh, equation 1, that has acceleration in it. Equation 0, that doesn't have acceleration in it, right? It's just x equals vt. But if you think back, this equation is only to be used when an object travels at a constant velocity, right? That means its speed doesn't change. Well, Winry, she was out there, she was sitting still, and she ran off. So how fast she was going changed as she ran. Can't use that one. Leaves us with equation 2, x equals 1/2 v1 plus v2 times t. Now, if we're going to choose one of the variables we want our classmate to find using the 4 equations, I want v2. In my case, I want to know how fast does my dog go. I'm curious. I've been told she's fast, right? People see her running, they're like, that dog's pretty fast. So let's find out. I'm just going to be kind of making up some numbers here based on things I know about her and I know about the situation. Just guesstimating, I think it took her about 3 seconds as she went from rest to her maximum speed, right? And I'm just eyeballing that. We don't have a lot of precise equipment here. We're all at our homes. But I'm guessing it took her about 3 seconds. I actually went back and looked at my security camera footage of when she did this and grabbed the time from there. You might just use your phone to get some video and be like, hey, it took about 3 seconds on my video phone, or however much you needed. And I went out and I laid out my tape measure and figured out she did this over about a distance of 10 meters. Right? So just look, I was eyeballing it and used a tape measure. You guys have those little roll-up tape measures that you could use if what you're looking at is small scale, but 10 meters is just a guesstimate. One nice thing about looking at Winry speeding up from rest, right? Her initial motion is 0 meters per second. She's just sitting there. It lets me know, hey, this is a nice convenient number to work with. Now, I decided I don't care about her acceleration right now. That's something I might find out about her down the road. But Acceleration's a number I don't have, I'm not going to need, and I don't care about because I picked equation 2. Has no acceleration in it. Units for that, though, are still meters per second squared. I like to throw the units in there even if we don't need it. And what we're looking for is our final velocity, v2. How fast does my dog end up going at her full speed? Down here, and now we're going to try writing this out in terms of a scenario, right? We're going to write this out like a practice problem. So, let's go. Winry, the dog, was laying on the driveway. When she saw her friend, speeding up, that tells us she's accelerating. We don't care about the acceleration, but that is what she's doing. Up for 3 seconds over a distance of 10 meters. How fast does she go? So now we have a math problem that our friends could go and solve, right? They could come in here and they could look at this and they could be like, oh boy, well, I see 3 seconds, that's time, right? And so in red, I'm just showing you what your friend might have to do down the road when they're looking at this. Here, time is 3 seconds. We know that she's going to be doing this over a distance of 10 meters. I want to know, how fast does she end up going? And here's where you might trip someone up. I know every year people sometimes forget this whole at rest thing, because I didn't tell you anywhere that she was going 0 meters per second at the start. And you can do that in your writing. I gave you the key, a little bit of a keyword. She was laying down on the driveway when she saw her friend, right? A good keyword to use for a lot of us is rest, but right now the situation fit laying down on the driveway. If someone's laying down, you know they're not moving. So I know V1 is 0 meters per second. If I look at my equations, I know I've got X, I've got V1, I've got T, and I'm looking for V2, so that would show me that I could use equation 2 if I was trying to solve this. Anyway, I hope this helps you get started with finding your own object that's moving, thinking about some of the variables and things you know about it, and how you could turn that into a problem. Now, you're going to have to eyeball or guesstimate a lot of these, and you don't have to actually go and collect true data out of a video. The point of this exercise is to practice writing a problem based around something you see in the real world. For me, I picked something I actually want to know. I want to know how fast my dog is. Now, you could always do that, or just pick something else interesting. Anyway, I hope you have fun trying to write a problem.